In this video, we're going to take a look at the collision test slider that's located in the button for third inside this interface, and the collision test slider can be found inside the content object. The pull down menu, when we pull down and release on the third button, passes an instruction to, of course, all the components that make up the interface, and it's inside the content object that we find this particular slider. So I'm going to double click and open that up. You'll notice if we scrub the time slider all the way over to the letter C, we can find the content slider. The slider located here is comprised of several components that make it work. The content, the sub-content, if you will, of this particular area is located in this object here, which is called images. And if I double click and open that up, you'll see inside, as I scrub the time slider through all of the various frame spans, that it's really just a series of static images. You could very easily park inside of each of these frame spans a complete sub-interface with its own internal navigation, flash animation files, video, and so forth. Let's go back up one level to the content object. The content object in this file, by the way, for your reference, is titled CONT. Of course, this sub-object here is called images, and to get to it, we'd pass an instruction from the root layer, the root level, to .cont to .images if we were to try and cause this to do something. The other key features here are the slider itself, which is given the name slider, as well as a series of graphics here do nothing more than locate a space on the screen. They're given a name, so each one is given a name: drop 1, drop 2, drop 3, etc. These are in fact movie clips, and if we open them up, you'll see inside it's just simply a graphic. It's a gray color swatch. There's nothing more to it. By virtue of it having a name and a place on the screen, we can produce a collision test. So we say if slider bumps into drop 1, 2, 3, 4, or 5, do something. To make this transparent, the alpha has simply been turned down to 0. Okay, let's look inside the most detailed part of this portion of the interface, and that's a slider. So at the top level of slider is a movie clip that simply contains all the stuff that makes this slider knob work. There's also an action at this level. Let's go ahead and open that up. At this level, we say on clip event load, and then we establish a series of variables that are used ultimately in constraining the limits of the drag placed on this slider. Top, left, right, and bottom correspond to the extents of the drag. So our top value is at most its current Y value. That's what this means. Underscored Y means the current Y value of the thing here on which this piece of action is placed, and its leftmost value is its current X, and its rightmost value is current X. That means it'll never move in the X direction, left or right, because at most it can only go to its original value. Okay? Just like at the top, at most it can ever do in the top direction is its current Y value. However, we have a bottom value which is its current Y plus 656 pixels. And what that corresponds to is the limit or extent to which we're going to allow this to be dragged. That's positive 656. That's positive going down, as you all recall. Next, I'm going to go ahead and double click and open up slider, and you'll see inside of slider is a button. Okay? And that button has an action on it, and this is where all the work is being accomplished. If we look at the actions inside here, you'll see there's some key functions. There is a set of actions that allow the slider knob to be dragged or to stop being dragged, and those both occur on press or on release, release outside. So on press, we have the function start drag, and then what follows in the closed parentheses after start drag are the arguments that constrain the start drag. In order, they are the name of the thing being dragged, and in this case, since we're clicking on the item that's actually being dragged, we have just a closed set of quotes here, and that equals this the thing being clicked on. You could also describe a path or a name in here and have a disconnected drag. That's for a future exercise. Following that is something called a Boolean. It's either true or false, and basically the difference is if it's false, that means wherever you click, that's where you drag from. If it's true, the cursor will automatically snap to the insert point of the thing being dragged, and it'll drag from there. Then it doesn't really matter what you call the next 4 items here, but they mean exactly what they say: left, top, right, and bottom, and that corresponds to the leftmost, topmost, rightmost, and bottommost extent of what's being dragged. And for whatever reason, they can be given any name you like, and it just strikes me as being most logical to give them a name that makes sense for what they mean. Following that is what happens when someone lets go. So they're pressing, it's dragging. If they let go, either by releasing or releasing outside of what's being dragged, stop drag is called. So this ceases globally any dragging that's taking place. And what follows is something called a conditional statement. And a conditional statement, Flash is going to be looking for any one of these conditions here to occur, and if it does, it performs a series of tasks. If it doesn't find that condition occurs, then it moves on until ultimately it restores this to some certain state if none of these conditions are to be found. So on stop drag, it's going to say if, and it's going to evaluate to see if the slider, which has this action after it called drop target, it's looking for an item that it's going to bump into, and the name of that item given here is drop 1. Okay, so you remember our invisible graphics that run down to the side of the page, each have been given this name: drop 1, drop 2, drop 3, drop 4, and drop 5. Note also that the name contains the total path to get to that particular item. So it evaluates to see if these two are sharing the same space. That's basically what that means here. Do these two overlap each other? And if they do, then it's going to cause the slider object to snap to this Y value. And what that Y value corresponds to is the location of the series of hash marks that are out here on the stage. That's why if you get close enough, it'll automatically pop onto that line. Okay? And then once it snaps it into place, then what it's going to do is going to pass a message to the images object. Remember, that's the big graphic box sitting out here on the stage, and it's going to tell it to play its A. And if that's the condition that's returned true, then this is done, and it basically is reset. If it doesn't find this condition, else if it tries to evaluate and see if the slider knob is equal to or overlapping space with target drop 2. And of course, if that condition occurs, we have a different outcome. We snap to a new Y with the slider, and internally on the images object, it sends the playback head to the B location, and so forth. So each one of these represent the outcomes that go with the true condition of the slider bumping into drop 1, drop 2, drop 3, drop 4, and drop 5. So the values of the Y are different, and they correspond to the location of these hash marks. Okay, so we have different Y values here. And of course, the outcome that we want then is for this condition to turn out true, we want it to cause this graphic here on the stage to switch to some new location. And that's all it really requires to cause this draggable slider to work well. Should you choose to have a slider knob that uses a more frequent set of collision tests, then I'd suggest that individual drop targets be made smaller. They should not overlap each other. You don't want two conditions to turn out to be true. That would cause a catastrophe for you. So make them smaller. They can't overlap. You could add as many in here as you like. You're just going to need to reconcile the math and the total number of items inside. And this could easily work in the X direction. Right now it's currently working in the Y direction, and you would just need to interpret the difference between this moving down in the positive Y versus moving positive or negative in the X direction.